Today is dealing with 5.2. 5.2 covers solving quadratic equations by factoring, and then we're going to dive into a new vocabulary word called zeros. And it kind of deals with this zero product property. If you had two real numbers, and we're just going to use variables for right now. If you have A and B be real numbers, if you have A times B equaling 0, that means either the first part is equal to 0 or the second part is equal to 0, or they both could be 0. It says example 11, but that's still from the factoring days. We're going to solve this equation, x squared plus 3x plus 2, and it's set equal to 0. We're going to solve this equation by factoring. The first target for this section is I can solve a quadratic equation by factoring. So what multiplies to 2 and adds and gives me 3? We get the numbers 1 and 2. So when we deal with factoring, so we've got two binomials. One of the binomials is x plus 1, x plus 2, but we've got to put them over the leading coefficient, which is just 1. So really I'm looking at one expression, x plus 1, the other expression, x plus 2, and they have a product equaling 0. When you have something times something equaling 0, if this x plus 1 represented the 0, because one of these have to be 0, if x plus 1 was the 0, what would x have to be? In order for this expression to be the 0, x would have to be negative 1, because then I'd have negative 1 plus 1, there's 0, times an expression gives me a product of 0. Well, what about this guy? And then this second expression, if you took negative 2 plus 2, that would become your 0. And then you'd have an expression times 0 giving you the product of 0. These two are your two solutions to this equation. In the next one, you figure out, well, what multiplies to negative 2? That adds and gives me the middle coefficient, negative 1. Should be a plus 1. In that second expression, if that had to represent our 0, z would have to be negative 1. You're going to have some problems where what if not everything is on one side? So these equations are examples of before we can factor, everything has to be on the same side. So let's move this, my bad. First off, let's copy it down. 16x squared equals 8x minus 1. And the strategy when you have something like this and you're supposed to solve the equation by factoring, get everything on one side. I would keep your quadratic term where it's at, and let's move the linear term and the constant. Be sure to divide by your leading coefficient, 16. We're going to reduce those fractions first, and then put the bottom up. So I've got two of the same expression. 4x minus 1 times the quantity 4x minus 1. If I want to figure out, now it's not so easy to figure out what does x have to be in order for this expression to be the 0. Sometimes we have to set up mini equations. If we set up a mini equation, how can 4x minus 1 be 0? If we set up a mini equation, then we can undo that with regular steps. Add 1 on both sides. Divide both sides by 4. So in this case, since both expressions look the same, we have one answer, and it's a fourth. In this one, it looks like, well, wait a second, couldn't we just divide by a z on both sides? Or strategy stays. You get everything to one side. Get everything to one side and set it equal to 0. We actually can factor this. Do you see how you can factor this? Or somebody tell me. When you just have two terms, Be aware you can have just greatest common factor, no multiply, add necessary. But let's talk about, wait a second, you have something times something equaling 0. What would this z out here have to be if this had to represent 0? So if you just have a variable by itself, that variable would be the 0. But what about this expression? Z would have to be 1 in order for this expression to represent the 0. These are our two solutions. Getting into the definition of zeros, what it means. We're going to find the zeros of this equation because it's all going to tie back to those graphs we had in 5.1. Zeros are like x-intercepts. Another reason why mathematicians like to use the word zeros is because x-intercepts have a y-coordinate of 0. So there's some type of number, comma 0. With that said, when you see directions, especially in the ACT, if it says find the zeros of an equation, that means your y-coordinate needs to be 0. So let's make that y-coordinate 0. So you go through the process again. I've got to multiply to -6, add, give me -1. You come up with -3 and 2. So you ask yourself, if this first set of parentheses, if this expression was your 0, that's where your 3 came from, because 3 minus 3 would get us the 0. If you had a -2 in this second set, the second parentheses would be your 0. Sometimes it's not necessary to set up mini equations like the previous example.